Hi everybody and welcome to the N Channel video blog. And today what I want to focus on is how to use a clamp meter. So let's get right into this. Now what a current meter allows us to do is to quickly take a measurement of the current being induced through a wire. And now this is an awesome little tool because now you don't have to break the circuit in order to take measurements. Now in general there's two types of current meters. There's ones that are just able to measure AC and there's others that are able to measure DC using the Hall effect. Now I'm not going to go into the details of how they work, I'm just going to focus on their operational function. Now traditionally if you want to measure current with a multimeter, you just have to break the circuit and plug it into the corresponding jacks to take the current measurement. Where when you use something like the current meter, you can just quickly throw it on and you have your measurement almost instantaneously. And this is great because first off, the main function that it plays for me is safety. Right here I have it set up for measuring current for a regular multimeter, and as you can see, it's not your ideal situation. Now I know there is some clamp meters where it is the multimeter itself, so you can take current measurements right directly and you don't have to worry about conversions or anything like that. Although they do exist, I'm not a huge fan of them. I prefer getting the combination of both, where you can throw this attachment onto your multimeter and take those massive readings as well as do the fine finesse work of electronics and take into account microamps. Now as you can see here I got two illustrations. First off, we have our classic multimeter measurement, where you have to break the circuit and throw your ammeter in series in order to take a measurement. And there are some pros and there is cons to this. First off, highly accurate. When you're using something like, your Fluke 289 here, you get monstrous results for accuracy. Where if you use something like your current meter, your results aren't as accurate. Now you also get direct readings. And what I mean is when you're using a clamp meter, you don't have a direct current reading. You get a translation. And what I mean is you get millivolts. And for the current meter I'm using it 1 millivolt equals 1 amp. And now that is a really nice friendly ratio to work with, but not all of them have that ratio. Next is the cheapness. This is a pretty decently cheap setup for high accuracy. But the problem is, this right here is not cheap. So when you start adding these features onto your multimeter, your costs go up massively. As well as the fact that multimeters themselves, if you start looking at the cons for the multimeters, they can't hit high currents. I mean, this multimeter right here has 10 amps. I mean, there's some that can take 20 amp measurements for, let's just say, 20 seconds, 30 seconds. And then you have to turn them off. Where this can measure up to 400 amps of current. And that's continuous operation. And you can get ones that hit up into the thousands. And when you're using your multimeter, it's not as safe. Like I stressed before, you start making little sketchy connections because there's a lot of exposed metal. And now you have to protect it from grounds. And your setup has a lot of time. So when you're breaking the circuit, you have to look at that as a consequence. So now if you look at the sketch for the clamp meter, you can tell that you don't have to break the circuit, and that's a huge advantage. First off, speed. You just go like that and you're done. Next is the fact of safety. I can't stress that enough. Safety is huge in this field. Electricity has the potential to kill, and anytime you're making and disconnecting, you have the potential to cause harm to you, machinery, anything. So I find these things a really safe operating system. Next is the fact that you can hit those high currents. Like I said before, with this one you can hit 400, but there's other models that can hit 3000 amps, no problems. So it's extremely awesome because once again your typical multimeter can only handle about 10 amps. Now the cons? Not accurate. These things maybe hit 5% accuracy. I mean there's better models which can hit that accuracy, but then your price tag goes up monstrously. So then that's the next thing is the cost. This costs about 400 bucks. So when you start factoring this into your multimeter, which you need to, do all these measurements, you're going to be really amplifying what your operational system costs. And there's not a direct reading. Now, like I said, 1 millivolt on this case equals 1 amp. So I know this isn't really stressing out the mind, but you do have to be aware that you do have to do some conversions. Now, another con for a clamp meter is the fact that you need a minimal magnetizing current. And what I mean is you need a minimal current flowing through your circuit before this thing will actually pick up a reading. Now there are some higher end ones that can take up milliamps and stuff like that, but then your price tag goes up significantly. For something like this, you need a minimal 1 amp flowing through your circuit before you can register a reading on it. Now when you are taking a measurement with the clamp meter, you can't just throw it onto the power line. You have to find isolated lines in order to do that. And that's because there's multiple currents running in here that cancel each other out. So it's one of those things that you have to be aware of when you're taking measurements. Now in order to take a DC measurement, what we're going to do first is turn this on. Then as you can see on the display screen right here, we have a negative reading of millivolts. So that just means we have to adjust this until we have a 0 reading. So it's just a quick little calibration and it works fairly well. When you get it on to your higher accuracy meters, there's a lot of distortion. And this is only for the DC, as you're only using the Hall effect for DC measurements. And so what I have here is a shortened out DC power supply. And I'm going to be running it at 2 amps. So just make sure if you're trying this at home that you have the voltage dropped way down low so you don't blow up anything. So once again, we just throw that on and turn it on, and as you can see, we're reading 2 millivolts right there. So what that means is that there's 2 amps of current flowing, and as you can see right there on the panel, that's what's going through our circuit. Now what I have here is a biscuit joiner, and what we're going to be doing is monitoring the current flow going into the biscuit joiner. So we're going to monitor the breakdown current and all that fun stuff. And as you can see right here, I have this circuit where I can get into one line. And I'm going to be using my Fluke 289, and I'm going to be using the min-max so we can see everything. Thanks everybody for watching. Don't forget to like, comment, share, and subscribe. Enjoy your week.